Hi, welcome to my first TwinCAT tutorial. I already made the project and called it Fun with Interfaces, so you guessed it, the tutorial will be about TwinCAT interfaces. So let's jump right into it. I already made an FB sample, which implements an iSample A, and the interface itself has nothing, no method, no property, nothing at the moment. And in the main, I instantiated the FB sample. I made a pointer of the pointer to the same FB, and I also made this interface. So let me get first the address of this of the FB. So this will be the pointer, and then we also have the so-called interface or interface pointer, which will also be assigned to that same FB. And then we will look at the memory consumption or the memory allocation of it. So let's log in, and we see quite interestingly the FB is the pointer to the FB is this address in the memory, and the interface pointer is like 8 bytes below it, so to say, in the memory. And then also let's see how the size of the FB is. Size of FB in bytes with this nice convenient byte size of operator in TwinCAT. So let's see, just quite like if I explore new concepts to look at the memory consumption to really get the kind of low level feeling about this stuff. Also here now the naked FB, so to say, allocates 16 bytes of memory. And now let's just add another interface to it. I log out for it. Also here there's the description of the infosys. An interface pointer stores the address of a function table or function block instead and implements the interface. So to say the function block in our case is the FB sample, and some function table of it can be the interface pointer then. And if we then add memories, that if we then add methods and properties, then we are able to access the properties and methods of that FB or of a subset of all the methods via this interface pointer. But let's first add another interface, I sample B. And now I let the FB implement both interfaces. Also, I forgot to assign it here as well. So now we have one FB and two different interface pointers to it and one pointer to the FB itself. And now let's see how this will look in the memory. Also, before it was 16, the FB allocated 16 bytes in the memory. Now it's 24, which is quite logical here because it always jumps like about 8 bytes in the memory. Also from 8 to 0, so to say, that's hexadecimal. So this is an 8-byte jump in the memory address. This also is an 8-byte jump. So we could add another interface and would see that we get another 8-byte offset, and memory allocation should also increase by 8 bytes. In total. So instead of 24, the FB probably then needs 32. I think though TwinCAT could round up the allocation if we would add integers and so to it. But in general, like what I want to say, the size of this interface pointer is 8. Each interface pointer has a size of 8 bytes, which it needs. So probably some sort of typo. Cannot convert FB sample to I sample B. Let's see what I did. Yeah. Made an FB and not an interface. That's obvious that this cannot be made. Now we add the C and also I will ask for the n size of interface. It should be 8 byte. Let's activate. So yeah, like we said already, the allocation needed for the FB is increased by 8 bytes, and also the interface itself has a size of 8. And you see it also here nicely with the memory allocation, that the pointer to the FB itself starts here, and then with an offset of 8 bytes each, the interface pointer start. So I think what the takeaway for us is that this, if you start with the interface concept, it kind of is maybe a little bit abstract, but at the end it's just another form of pointer, so to say, and it just really is some address in the memory, and via that address we are then later able to access the methods and properties. And then the fun stuff, so to say, begins. So let's add some methods and properties to it. I think what we could do here is, yeah, I will make a number a of type integer, and I will give the first interface the possibility to set this number and get this number in a number a of type integer. I think I had chosen, and then just okay, some, yeah, sorry, of course, it's in the interface and implementation. Of course, in the interface itself, you cannot have an implementation of the getter and setter. You need the implementation, of course, in the FB itself, because like the interface is just like a template. It doesn't contain implementation. It just tells the FB what it needs to implement, and also tells the user of the interface which methods are in there, but not how they are implemented. So implementation is here then in the FB sample, and we just make the getter and setter. This will be our first interface. Then we say we have some boolean be on of type bool, and then we say we will make in the second interface the possibility to get and set this boolean. Also, the implementation is of course here. Again, just quickly implement the getter and setter. Just kind of boring thing to do, but will then helps us later. And then we will access it from the main. So we are back in the main, and there we have a simple example. As soon as the FB is set to on, then we will increase the number each PLC cycle, and we can just do it now via the interfaces. So as soon as we set with the interface B, we will set it with a variable here, be on bool of type bool. As soon as we set the FB to active via the variable b1 or the property b1 be on, then we will increase the number by 1 each cycle, and the property here then we'll set this internal variable where I had a typo. Of course, it must be here. That looks fine. Looks also fine. Yeah. And so now we access the on status or set the on status via the B interface, and this leads to increasing the number of the FB via the A interface. So let's see if that pans out. Then I will just put these two variables to watch. Let's set the on variable, and then it should count, which it does not. So probably we have some error still here. Let's see. It doesn't set this to on. Oh yeah, that was wrong. Sorry, that must be in the other direction, and the set must be in this direction. Yep. Now it should work. 2 typos in a row, or 2 small errors. Yeah, that works now. If I set beyond to false, yeah, perfect. So you may ask, okay, what's all the fuss? I could just achieve it with just directly accessing the FB. I think the one thing you have to keep in mind here is here you can really separate who is able to control which method and functions. For example, it can be that this FB really contains all the logic you need for your task, but you only want to give, like, imagine this being some interface to the HMI, and you want to give one part of your program the possibility to set the counter to on and off, but you don't want it to have the possibility to interact directly with the number, so you can separate this. Of course, you could give an FB the full control with the whole pointer, but here with the pointer you really have access to everything. So a pointer can really do everything. So what we in Autolab often use for interfaces, for example, I have something like this, that I have some FB axis that controls an axis, and then I have let's make a very simple example, and I have some f move absolute method, and I have some properties, like for example the property that it's busy, the property which position it is, and of course the FB axis would have a reference to the axis and everything, but just to make it clear, so to say, then we would make something like an interface E control axis info, and I control axis commands or something like that. And then, like, I would say that this extends the info one, and the info axis only really gets information stuff, and the control commands really gets the control stuff also. And then this would look like, so if I now instantiate these two interfaces in the main, so don't like the naming, I will rename it to control access and access info. I think that's cleaner naming, more clear, so to say, and access info. So if I can make this interfaces, and here I would have the possibility to, like, for example, I give some FBs that only need the information from it. This interface, it's only the older FBs that get, for example, I could have some FB HMI handler that gets all information of all access, and then I have really an interface which I give to some controller that controls the access, that of course would get the whole interface. So you could with the interface you can really separate between you can separate which part of your program has how much control on the FB. If you just would use raw pointers or reference, you always you only have the possibility to give full control to some FBs. Like if I have instantiate this FB access also here, I really have and the pointer, sorry. Yeah, then you give full control to the if you give some part of your program the pointer, you always give full control to the FB. With the use of interfaces, you are in control of how much access you want to give to your FB, and that may sound not too important for small programs like here in our test scenario, but if you have like huge code bases, large libraries, large projects, such thing will get more and more important, and you should really think of the use of different interfaces and provide the access needed, but not too much or not all the access always.